Hello and welcome to this section of the Algebra Tutor. In this section we're going to continue talking about polynomials, and specifically we're going to talk about how to add and subtract polynomials. And so it's very, very important to understand when you can add things together in algebra and when you can't. And when I say add them, I also mean subtract them. So anytime you can add them or subtract them is something that you're going to have to master, because you're going to constantly be dealing with situations where you're simplifying expressions, so you'll have to know when you can add terms together. And in these polynomials, when you're adding one polynomial to another polynomial, how you can actually combine the terms together and make it simpler. That's what you're really trying to do when you add things together, is to add it together and to simplify it. There's one rule that you need to understand in order to be able to know when to add and subtract polynomials, how to combine the terms together properly. And a lot of students think it's this mystical thing and it gets very confusing, but there's only one rule that we're going to learn in this section, and it's so easy once you understand that. So listen carefully. The only way you can add or subtract terms from polynomial to polynomial, or from expression to expression, is if you have like terms. The only terms that you can combine together and add or subtract, they have to be similar. Let me show you what I mean by that. It's much easier to give an example than just to talk about it. So what if I have, forget about polynomials now for a second, let's just say I have 3y, I'm going to put a comma here, and 4y. And let me ask yourself, or let me ask you, are these terms like terms or not? Are they similar, in other words? The answer is yes. These guys are basically what we call like terms, right? And the reason that they're called like terms is because they both have y's here, okay? So this is 3y's, 3 times y, right? 3 times the value of what y is. And this is 4 times y, 4 times the value of whatever y is. But in both cases, I'm talking about something multiplied by y, and here I'm talking about something multiplied by y. So ultimately, I'm kind of talking about, I'm dealing with y. I'm not dealing with y squared. I'm not dealing with y cubed. I'm not dealing with, y times y cubed or y times y squared. I'm only dealing with y. So these things, even though they have different numbers in the front, they're similar, right? So if I wanted to add them together, for whatever reason, so if I wanted to add these two terms together, the sum would be, what do you think it would be? Well, 4 plus 3 is 7, and I'm still talking about y, so I have to keep my y along for the ride. So if I were to add these two things together, I would get 7y. So when you start thinking in terms of algebra, you need to start thinking in terms of when you can combine things together if you're trying to add them together, right? So here, this is a like term with this because I'm both talking about whatever the value of y is or whatever the idea of what y is, right? What if I ask you, as a similar example, what if I have 3 apples as one term and 4 apples? Right? So obviously I'm drawing a comparison because I have 3 and 4, but let's just say I have 3 apples and 4 apples, and I asked you how do I add them together. Then it would be easy for anybody watching this video to say you have 7 apples, right? So I would say the sum is 7. 7 what? 7 apples. It makes sense to us when we talk about apples because we know that apples are this nice, delicious thing that we can eat. And if I have a bucket of 3 apples over here and a bucket of 4 apples over here, that's easy. We understand that we can add those together and we can get 7 apples. But when you think about it, the only way that you're really allowed to add these apples together is because you're talking about apples in one bucket and apples in the other bucket, right? What if I had apples in one bucket, like 3 apples or something, in the other bucket I had, ping pong balls, right? So apples and ping pong balls, right? I could add them together. I could add the numbers, but what would it mean? I would just be getting the total number of objects, I guess. That kind of makes sense. But it doesn't really make sense because in real life, it only really makes sense to add things that are similar. If you're trying to get an answer that is representative of the whole unit, it only really makes sense if you're trying to add like things together. In terms of algebra, it's the same way. It only makes sense if you're trying to add things that are similar to one another. So you can add apples to apples. And yes, in real life, you can add apples to oranges, and I guess it would represent the total amount of fruit you have. But in terms of algebra, you want to group things into these like buckets in order to be able to add them together. That's why we're able to add 3y and 4y, because basically they look the same. The variables match. They look exactly the same in both cases. So knowing this, what if I give you a term, 3x and 3y, two terms, 3x and 3y, and I say, hey, add these together. Well, you're going to immediately look at this and realize that these are not the same. Yes, I have 3, and yes, I have 3. But this is an x and this is a y. These are different. This could be water buffaloes, and this could be, skyscrapers. I mean, I could add them and get 6, total sum of everything, but I don't want to do that. I can only really add things together in algebra that match. So this is really unlike terms. So, a lot of times in algebra you start learning about like and unlike terms, and the reason is because you can only add things together if they're like, if they're similar to one another. So if your exam or your teacher says something like, circle the terms that are similar, circle the like terms, you're only going to circle things where the variables match exactly like they did up here. X and Y don't match at all, so you're not similar terms, they're not like terms, and because of that you can't add them. If you had a plus sign between here, then you'd have to leave it like that. You couldn't actually do the addition in terms of algebra. All right, so let's do another example. What if we had 3 terms, 3x cubed, 4x cubed, 6x cubed. Are these like terms or not? Well, here I'm talking about x cubes. Here I'm talking about x cubes. Here I'm also talking about x cubes. So these are like terms. That means that this might as well be watermelons, watermelons, and watermelons. Now, everything has to match. The x has to match, and the exponent has to match for them to be like terms. If one of these exponents were different, then it wouldn't be like the other ones. Everything exactly has to match. So if I wanted to write the sum, 6 plus 4 is 10. 10 plus 3 is 13. 13 what? You're still talking about x cubes. So whenever you add things together in algebra that are like terms, you add the numbers together like usual, and you have to carry along whatever it is you were talking about. Because this is like 3 pencils, this is like 4 more pencils, and this is like 6 more pencils. So that's 13 pencils. If you don't put the x cubed, then it's not referencing what we were adding together to begin with. All right, let's go do another one. Let's say we have negative 5x cubed times y squared. Next term, 13x cubed y squared. Final term, actually that's the only 2 terms I have. Are these 2 terms like terms or not? Well, there's numbers in front, obviously. Here I have x cubed y squared. Here I have x cubed y squared. Everything matches exactly. The x matches the x, the y matches the y. The cube on the x matches the cube on the x. The square on the y matches the square on the y. Because everything matches exactly, these are like terms. If anything were different, they wouldn't be like. If I cover up this and make it y to the first power, then these are not like terms. Because everything has to match, everything after the number. Right? So because these are like terms, I can take negative 5 plus 13, which is the same as 13 minus 5, and the sum is 8x cubed y squared. And you have to carry along whatever it was we were talking about. We were adding up, bulldozers and then more bulldozers. So our answer is going to be in terms of bulldozers. I'm kind of using analogies here to tell you that when you see these things here, you got to start looking at your grouping. This is something, this is something. I have to have that something in the answer because that's what I was talking about the whole time. So let me go ahead and erase the board, and we'll continue to work some more of these problems to drill this in. All right, what if I have negative x squared times y? The next term is x times y, and the next term is 3 times x times y squared. And the question is, are these like terms or unlike terms? Well, if you're not experienced in this, you might say yes, because you have an x here, x and x, you have a y, and a y. But hopefully you've realized that that's not true, because the exponents are all different. Here I have x squared, x, and x. Here I have y, y. These match, but this one's different. So if I'm going to say that all of them are like terms to one another, then they all have to match exactly. They all have to have the same variable and the same exponent everywhere, and of course these don't match, so these are unlike terms. Which means if I were trying to add these together, I could not do it. If you try to put plus signs here and plus sign here, then you just literally have to leave it like that on your paper because there's no way to add these things because they're unlike. They're nothing like one another. So in terms of algebra, you just can't do anything if it's like that. What if we have something like, now let's actually get into the actual addition, negative 8t squared minus 4t squared. So here is a term, This is a binomial, right? Which is a polynomial with two terms, right? So let's say we want to combine these guys together, all right? Or see if we can combine these guys together. Well, do I have like terms? T squared, they match. I do have like terms, so now I can add or subtract the numbers that are in front. So negative 8 minus 4 is negative 12, and you have to carry along whatever it is you were talking about. So it's negative 12t squared. All right. What if I had 18 x to the 5th power times y squared minus 11 x to the 5th power y squared? Can I subtract these? Well, you look at this and you say, can I subtract them? Well, I have x to the 5 y squared, x to the 5 y squared. They match. These are like terms. So I can take 18 minus 11 and I will get 7. 7 what? X to the 5 y squared. It just comes along for the ride because this is like peanuts, subtracting some more peanuts. I'm going to get however many peanuts left. Everything matches. Everything has to be carried along. So this is the answer, 7x to the 5th y squared. Okay? Switch colors. Let's say we have 3 times r times s times t plus 4 times r times s times t plus 7 times r times s times t. Can I add these together? Well, RST matches RST matches RST. The the variables and the exponents match for every term that I have, so these are all like terms. 3 plus 4 is 7, 7 plus 7 is 14. 14 what? RST, because that's what I'm talking about. That's what the whole problem was about. That's what I was adding together to begin with. All right, so let's go ahead and do a different thing. Let's say we have 3x squared minus 4x squared plus 10x squared. And the question is, simplify this expression as much as you can. Well, you know you're going to be able to combine these in the end because I have x squared and x squared, but what about this guy? This is 3x raised to the 2nd power, but we've learned that anytime we have that, we apply the exponent to both places. So 3 squared is going to give me 9, x squared is going to be x squared, and then I have minus 4x squared plus 10x squared. And I look at these and I say to myself, are these like terms? X squared, x squared, x squared. Everything matches, so I can just add the numbers together. 10 plus 9 is 19. 19 minus 4 is 15, so I'm going to have 15. 15 what? I'm talking about x squared, so 15x squared. So that's the final answer there. It's very simple. It's like a matching game, actually. Once it looks complicated when you first start algebra. All the stuff looks complicated, but then you start realizing, like, oh, it's easy. All I'm doing is looking to see what matches, and when it does, I can add them or subtract them. All right, so let's have 5x squared y squared plus 2 times x times y squared minus 3x squared times y squared. So some of these problems are getting to look a little bit weird to force you to kind of use some of the knowledge that you've used before. We know here that when we have a parenthesis with things inside of it and the exponent is outside, that applies to both, we just apply the exponent to both cases. So what we're going to have is 5x squared y squared, this just stays along for the ride, plus 2. X, with the exponent applied, is x squared. Y squared, this because y also has the exponent applied. And then when we get to this last term, it's a little silly that it was grouped like this to begin with. 3x squared times y squared. You really don't need these parentheses. A lot of times on tests, they'll give you a parenthesis, but it doesn't really matter because there's no exponent applied out here. There's no number out front that needs to be multiplied in or anything. So it's really just sitting there for no real purpose. There's nothing added together inside, so I can just take them away. And now I look and I say, can I simplify what I have left? Do I have any like terms? Well, I have x squared, y squared. Here I have x squared, y squared. Here I have x squared, y squared. Everything matches everywhere. The exponents matches, the letters match. So I can add all of these together. 5 plus 2 is 7. 7 minus 3 is 4. 4 what? 4x squared, y squared, because whatever it is I'm calculating has to carry along through to my final